Hey everyone, and welcome to The Explainer. Today, we are going to solve a frustration we have literally all experienced. Those annoying audio hums, random video static, and those mysterious signal drops that just plague our tech. I mean, we usually look at the wires behind our desks and just see this tangled, dusty mess of plastic and copper, right? Well, by the end of this explainer, you're going to understand the highly engineered pipelines hiding right behind your devices. We're diving deep into the microscopic construction, the physical defenses, and the honestly brilliant engineering of electronic cables. So here is our roadmap for today. We'll kick things off with the war against noise, move into the anatomy of audio cables, check out the types of audio cables, then decoding RF cables, and we'll wrap it all up with multitasking combo cables. Let's get right into it. Section 1. The war against noise, defending the signal. Okay, so to truly understand this war, we first have to figure out exactly what it is we're trying to protect. Audio cables carry a very, very specific payload, which are audio frequencies. These range from 20 hertz up to 20 kilohertz. Now, why does that matter? Because that is the exact spectrum of sounds audible to the human ear. Any information floating around inside this range is what we call our wanted signal. It's the music you're jamming to, the voice you're recording, or the VIP data that absolutely must get from point A to point B completely untouched. But, it's a pretty hostile environment out there for these signals. On one side, we've got our delicate, wanted signals trying to do their job. And on the exact opposite side, we have unwanted signals. These are the invisible enemies. Things like crosstalk, hum, and electromagnetic interference that are just constantly bombarding your cable from nearby power cords and radios. So the equipment actually has to be specifically engineered to handle those wanted signals while vigorously, and I mean vigorously, rejecting all that outside noise. Moving on to Section 2, Anatomy of Audio Cables, the Layers of Defense. Imagine peeling back the layers of a standard audio cable, almost like an onion. Right in the middle, you start with the conductors. That's the copper actually carrying our precious wanted signal. Around that, you have a layer of insulation. But here is the critical part. Wrapped around that insulation is a metal mesh shield, and then the whole shebang is safely enclosed in an outer PVC sheath. This copper mesh, it isn't just there for structural support. It acts as a literal, physical defensive screen. When it's grounded at both ends, it creates a barrier that intercepts all that outside interference before it ever gets a chance to reach the inner conductors. To really underscore just how crucial this is, remember that this shield surrounding those live leads runs continuously throughout the entire length of the cable. No gaps. This continuous copper armor is absolutely vital. It is the only way to make sure the delicate signals on the inside remain perfectly isolated from the chaotic noise happening on the outside. It's basically a highly protective, dedicated tunnel guarding your audio all the way to its final destination. All right, Section 3, Types of Audio Cables, Tools for Specific Jobs. You wouldn't use the same cable for a delicate studio microphone that you'd use for a massive data transmission line, right? For circuits that are mostly stationary and handling low-level signals, a standard round cable with a braided screen works beautifully. But microphones, they present a really unique challenge. They have to be highly flexible. Think about a lead singer sprinting around on a stage, while still demanding exceptional screening against noise. So, to solve this, flexible microphone cables use a single lap screen constructed from plain annealed copper. It's honestly a brilliant compromise. It perfectly balances flexibility for the performer with the robust noise rejection the audio needs. It all comes down to matching the physical defense of the cable to the specific vulnerability of your signal. For microphones and preamps, you absolutely need low-noise shielded cables, period. Now, if you're wiring up line amplifiers or audio consoles, standard audio cables with cotton-braided shielding are going to be your go-to. But what if you're running robust data transmission lines? Well, then you graduate to heavy-duty audio cables. These beasts feature multiple cores that are individually screened for maximum protection. Now, before we completely leave the audio world, we have to mention the humble speaker wire, often known as a zip cord. Unlike the delicate, quiet whispers of a microphone signal, the amplified signal traveling to a speaker is incredibly loud and super strong. And because of this, it can actually get away with skipping that expensive, heavy metal shielding entirely. Instead, the absolute most critical feature of a zip cord is careful marking to identify the correct audio signal polarity. That just ensures your positive and negative terminals are matched up perfectly so you get accurate sound reproduction. Section 4. Decoding RF cables, high-frequency pipelines. Let's shift our focus to high-frequency radio frequency, or RF cables. These are the ones used for video, transmission lines, and antennas. In this world, you'll constantly see ratings of either 50 ohms or 75 ohms. Now, these numbers aren't just your standard resistance. They represent what's called characteristic impedance. Think of characteristic impedance as a vital specification that dictates exactly how efficiently the pipeline handles different transmission links and high-frequency environments. Matching the impedance of your cable to your specific equipment? Yeah, that is totally non-negotiable if you want to avoid signal reflection and data loss. So how does this actually play out in practice? Well, let's take the RG58C/U. It's a 50 ohm cable, it's exactly 5 millimeters thick, and it has an attenuation of 3 decibels per 10 meters. Because it's thin, it's perfect for short-length runs. But compare that to the RG59B/U. This 75 ohm cable is slightly thicker, but its attenuation is much lower. Only 1.9 decibels for that exact same 10-meter stretch. Because it bleeds out less signal over longer distances, this 75 ohm option is the undisputed champion for general-purpose video cabling. Finally, we arrive at Section 5, multitasking combo cables, the heavyweights. Modern installations require modern heavyweights. We're talking cables designed to carry completely different types of signals, all at exactly the same time. Take the RG59 coaxial cable plus a 2-core power CCTV cable. The industry actually affectionately calls this a shotgun cable because the two distinct lines run side by side, joined right down the middle, kind of resembling a double-barreled shotgun. By bundling the power cores right next to the video coax, you end up saving massive amounts of installation time and money. Why? Because you're only pulling one single cable through the walls instead of 2. Once you're done, you just pull them apart at the ends to connect your DVR on one side and your power source on the other. Pretty clever, right? Now, for even more demanding setups, the PTZ, or pan-tilt-zoom cable, is a true 3-in-1 powerhouse. It safely isolates your data, your video, and your power lines all within a single heavy-duty jacket, and the engineering here is just beautifully practical. The power cores use tightly stranded wire to prevent physical breakages, which is crucial since the security camera is constantly moving and panning around. Plus, they are strictly color-coded red and black to absolutely avoid expensive, time-consuming connection errors out in the field. These power cords are actually so robust, they can even be used to run 24-volt AC. So we have journeyed from the microscopic copper mesh shielding our delicate audio, through the tricky impedance balancing acts of RF transmission, all the way to the brute force efficiency of modern 3-in-1 combo cables. Armed with this new understanding, I guarantee you'll never look at that spaghetti of cables behind your desk the same way again. Next time you peer behind your TV or your sound system, are you just going to see a tangled mess of dumb wires? Or will you see a highly engineered, frontline defense actively fighting against invisible noise? And as our entire world pushes further and further into wireless technology, it really makes you wonder, how will this war against interference evolve next? Thank you so much for joining me on this explainer. Keep learning and stay curious.